All right, we are welcome once again. Um, you're welcome to Southgate Internet Free Training. So we are Southgate Internet, and what we do basically is IT related. It's an IT related organization with a goal and vision of implementing analytics application, deployment of software applications, and training on analytics such as big data, artificial intelligence, data visualization, and the list go on. So we are located in Lagos and we've been in existence for over going to 4 years now in Lagos, Nigeria. So what are we discussing today? We just want to run through what our company does, we what we do and why we do what we do. It's an innovative company. We are into different kinds of solutions. We are passionate about data. We are problem solvers, and we develop custom-made applications that are targeted to your need. And what are our promise to our clients? Promise our clients we have a clear understanding of the problem. We collect the right information from our clients. When we get the right information, we are able to deploy some kinds of analytics and powerful reporting to go along. After we've understood the problem your organization has, we are able to create a solution and give advices and guidance as the case may be, because we have skilled personnel working with us. And some of our services I mentioned earlier, some of them are visualization, data visualization, and consulting. We consult for your company. We do some programming. So those are some of our services. And the list go on, and we do training and coaching. Some of our clients are listed above: Access Bank, EcoDisco, Interconnect, and Canter House in Nigeria. Well, our clients are still local. We've not broken yet to the international market. So my name is Nii Moluga, and I'm going to be your instructor for today's training. Our handles are displayed on the screen. LinkedIn handle, our Instagram handle, our Facebook handle, our Twitter handle, and our email. You can also visit us on our website www.sgdatanet.ng and find out more about the services that we offer. So we are going straight to the topic for today. We are going straight to what brought us here, which is database design. And I hope we all were able to follow the mail that I sent you. I sent you a couple of mails detailing the instructions on how to set up your laptop, how to set up your system for the training today. And I hope we've all done that, because it's part of what we're going to use to go on in today's class. If you follow the instructions I gave you, I would like you to say hello. I would like you to say hello. If you've been able to follow the instructions I sent in the mail, kindly say hello. If you had challenges, kindly let me know also. Tell me the challenge you encountered while installing it, and say hello if you had no challenge. All right. I assume you can still hear me. Can you all still hear me? If you can hear me, type hello. Type hello. Type hello if you can hear me. All right. Okay, I can see your chat coming in. Tolu is saying hello. That is fine. So we're going to go straight to today's class. We're going straight to today's class to start as we heard. So today we're going to be talking about database design. Database, can you see my screen? Database design. So for me not to distract, I'm going to stop the video for now. And when it's necessary for me to bring the video, I will definitely shoot it up so that we can all continue. All right. So we are going to be talking about database design. And before we start the database design, I would like to explain some fundamental things you need to know regarding database. I need to explain some key concepts so that as we go along in the design, we won't be confused about some terms. So I need to define some terms, define some processes, define some architecture, and lay the foundation for this class for us to continue, because it's very important that those foundations are laid before we dive into the software I told you to install. It's very important that some key foundations are put in place. So before we continue, I would like to explain some key concepts that will help us. Well, when we hear about database, a lot of us just when we want to talk about database, we talk about the features the database has, we talk about the specification of the database. But when it comes to database, one thing we should know, just like any other software, they are made to solve some particular kind of problem. And what is that problem they are meant to solve? Because if you don't know the purpose of a software, there is a high tendency that you are going to abuse. What was a database created for? Basically, they were built to solve the problem of storing information and allowing you to be able to access the information at one point or the other. To access the information using any procedure you might think of, whether you want to access your data through the software or you want to access your data remotely from another application, necessarily not where database is stored. Alright, so what are some of the information that can be stored in the database? To store names of employees or description of items that are ordered, or amount of goods that are sold, or files. To store files in the database like pictures, images, music. Alright. So they are created to store information, and this information could be like I listed here, could be your personal information, it could be your business, organizational information, your client information, or you just want to store the visit of people to your website. The list is endless of what you can do with your database. I just listed a little few. So the next question that will come into mind is, so why use a database? Why do we need a database to store our information? Why can't we store our information in a spreadsheet like this, like the one we see here? Well, that is a valid argument, but the reason why you cannot, I'm going to give you some problems that are associated with storing your information in a spreadsheet. Storing your information in a spreadsheet like this, as you can see on my screen, there are so many disadvantages of you storing your information on a spreadsheet like this, and those are the problems I've listed here. Some of the problems are the size ease of updating, accuracy, the security, the redundancy, and the importance. So I'm going to explain each key point I've listed here. When you talk about the size, you know, you could look at your spreadsheet as okay, my spreadsheet is as an Excel sheet. You have few lines. Maybe you have 200 lines or 200 rows in your spreadsheet. You know, over time, this spreadsheet can grow. When you keep storing information into it, this spreadsheet can grow and grow to hundreds of lines, hundreds of rows, thousands of rows, even millions of rows. So in that situation, when you have a spreadsheet that you keep updating and updating and updating it, it's possible for the spreadsheet to grow extensively. What happens? How do you search for data when such spreadsheets grow? And how do you decide? When do you decide to create separate files? How do you link the sheets together? You can decide to, this spreadsheet is voluminous. I have to create a new one. So how do you correlate the two separate spreadsheets together? How do you connect them together? You can see that's the problem there, because your spreadsheet could grow enormously and you want to create a new spreadsheet. How do you link those spreadsheets together? You are looking for information in one spreadsheet A. You search and search is not there, not knowing that it's in spreadsheet B that you have saved with another file. That's some of the problems. Then the ease of updating. This is a peculiar problem. It's possible for two or more people to update the record in a file. This means there will definitely be overriding of information. It's possible for Mr. A to edit that spreadsheet, and Mr. B access the spreadsheet again and changes and alter what Mr. A has already done. That's an override. When you store something on an Excel sheet, then I come and use the same Excel sheet and update and edit it. There is an what you've done, I've overridden it with what I have. That's the problem with that spreadsheet when you want to use a spreadsheet. Then the other challenge we have is the accuracy. See, I said that is there anything that can prevent me from entering the wrong data into the file? In your spreadsheet, you can't really constrain people from entering the wrong information into the spreadsheet. Our spreadsheet, has rows and different columns. So in that your spreadsheet, can you put a constraint that will, if you have a column for date of birth, can you put a constraint that will prevent me in the column for date of birth, I now decide to write an list of alphabets inside? The spreadsheet will definitely take it. You can't really put constraints. You can't really define rules and restrict the kinds of information that are being entered into the spreadsheet. That's one of the problems. Then another challenge will be the security. Not all information are supposed to be available to everybody in the organization. There are some levels of information that is only accessible to some categories. You can give privileges to some. You can give privileges to view some particular part of the data. But in a spreadsheet, this is a challenge because every of the information in the spreadsheet is available to all. Then the redundancy. This is a situation whereby you have multiple entries of the same record in a file. In database, this is dealt with. There is no redundancy. But in a spreadsheet, I could have repetition of same record repeating itself several times in the spreadsheet. This is redundancy. Then the last one is the importance. Most times, spreadsheet it's possible that for there to be crash in your spreadsheet. You are using your spreadsheet and there's a crash. This happens a lot with Microsoft products. There's a crash and you will see the spreadsheet will just close automatically, or will tell you Microsoft Excel has stopped responding. What do you do in such situation? Just know that two things are bound to happen. Is either information you wrote last, updated last, is lost, or the information or the spreadsheet itself is corrupt. and once you open it, it starts giving you error. You can't open it anymore. All your information are lost. These are some of the challenges that happens using a spreadsheet for your database. So now what are the solutions? The solution is just a database, because a database is scalable, it addresses all the problems I've stated earlier. It's accessible, it's accurate, it's secured, it's consistent and permanent. So those are the solutions you are to derive from using a database management system. So what does database? Database gives us structure, and the structure are enforced by a set of rules. Database is a structured system, and they are enforced by a set of rules. They are enforced by a set of rules. So, what is the difference between a database and a database management system? What is the difference? Because a lot of time people mix this thing up. They mention database when they are supposed to mention database management system. And they mention database management system when they are supposed to mention database. These are two conflicting things, and I'm going to explain them here. So as you can see from my screen, database management system, which are shortened DBMS, database management system, are the software vendors that have created them, such as Oracle SQL Server, MySQL, PostgreSQL, and MongoDB. These are what we call a database management system. It's a suite of applications, and it's quite different from what we call database. We use a database management system to create a database. You get it? We use a database management system to create a database. So the database is a byproduct of a database management system. Without the database management system, you cannot create a database. So for you to create a database, build a database management system, you either use Oracle, you either use SQL Server, you either use MySQL, you either use PostgreSQL or MongoDB. So those are the ways you can create a database using a database management system. So the next thing I would like to share is, you can see in the diagram here, I put a database management system and database inside. So in your database management system, you could have several databases. The database is your data, and you have as many databases as you want. You could have customer database, employee database, and so on and so forth. While the software for creating a database is the database management system. So you can see I have the diagram here. So it's possible for your, and it's also possible for your organization to have several database management systems for various reasons as peculiar. The reason is, it's possible for your company to be using Oracle, to be using MySQL, to be using SQL Server. All these database management systems are good, but they are good. They have different strengths. Some of them are good at different things, and your organization might want to leverage the various database management systems because they've noticed that they are good in particular area. So they might want to use several database management systems. It's also allowed. So don't forget, we'll be talking about relational database management system, RDBMS, which are the Oracle, the SQL, the DB2, MySQL, Postgres, SQLite, Microsoft Access. There are other kinds of database management systems. We have hierarchical database management system. We have network database management system. We have object-oriented database management system. We have NoSQL database management system, and so on and so forth. So, but we are going to stick to the DBMS, Relational Database Management System. Why are we sticking to Relational Database Management System? The reason is simple. They are the most widely used. they use the same principle across all offerings, in the sense that when you are using Oracle or you are using SQL, you are using DB2, the procedure is the same. The procedure for using is almost the same. And if you have a foundation in this one, you can also use any other database management system. What are the features of a relational database? What are the features of a relational database? Quite simple. A database contains a component called table. So a database without a table is just an empty shell. There's nowhere data will definitely sit in on that database. So table is a fundamental component of a database. You could have as many databases as you want, but the fundamental component in the database is the table. Without the table, you don't have any database. It's just like having an empty shell. You can look at your table, like look at the diagram I have here. You can liken your table to this kind of diagram. A table consists of rows with vertical, horizontal line, and also columns with vertical line. It consists of rows, the horizontal line, and the vertical line are called columns. You can liken your table to a spreadsheet like this. Can we all see the screen? If you are following, just say hello. If you are following, say hello. If you can hear me, say hello on your chat. Okay, I can see your chat. That's good. So we continue. So our database has a table, as we said earlier, and the table is where your data sits on. You can liken your table to having rows and columns, as I said earlier here. The table having rows and columns, just like I said earlier. Here, you can see the columns and you can see the rows. The columns are the purple, while the rows are the green line. And what do this table do? They store information. So a typical table stores information like this. You can see this table here is information about different categories of people. We have a table here for employees, and in this table we have several columns and several rows. As you can see, the columns are the vertical, while the rows, Alice, James, Calista, Faye, are the rows. And if you look carefully, each column, just like the first name, last name, hire date, grade, and salary, have an additional information written on the columns called text, date, numeric, currency. We will get to this much later in the course. I will explain what they do later in the course. But for now, just know that those columns have data types, and those data types are text. So first name has a data type of text. Last name has a data type of text. What do I mean by data type? It means the kind of information you want this column to store. You want it to store names. What are names? Names are basically text. Names are basically alphabet. But in database, we don't use alphabet. we consider them as text. So we set them to be variable, to be called text. That means they store only text. In that column, you cannot put integer, you can't put numbers. If you look at the grade column, the grade column is numeric, meaning in that column you can only put anything that is numbers, whether it's a float, whether it's an integer. Floats are with ones with decimal point, maybe 4.06, 3.01. Those are floats. That is still categorized as numeric. But in that grade column now, you cannot put alphabet, you cannot put text there. So that numeric means it can only store information that are numbers. So we are moving ahead, and we're going to discuss about, we are still focusing on the table, and we're going to take it a step further, looking at the table and explaining some key features a table is supposed to have. And in this topic, we're going to discuss about, okay, a table must have what we call key, a unique key. What's the function of that unique key? A unique key is a key that identifies one particular row within a table. So if you look at a table once again, there must be a unique key that will say, okay, this row is unique. If you look at this table I have here, the unique key I have are this 153, 374, 352, 376, 153. So the unique key are also called primary keys. The reason why we have a unique key, or we can also call it primary key, is to be able to differentiate every single column in that table. We know it's possible for two people to bear the same name or the same surname, although it's rarely possible. But for us to have no conflicting rows in our table, we normally identify each row with a primary key, and that primary key is always unique. It's always unique because we always want it to serve as a unique key that prevents repetition of rows. So that is what a unique key, and we'll be working with it a lot in this class. But by the time we start the practical session, you will be able to understand in detail what the unique or primary key does. So after defining our table, the next thing to do will be to define the relationship between those tables. Now that we have a table, we could have several tables in the database. If you have a database called University Management System, in that database you could have several tables in it. You could have a table for the students, you have a table for their subjects, you have a table for all sorts. Just like we have a table, look at this, our table now. Here we have three tables. We have a table called customer, we have a table called order, we have a table called product. Customer, order, and what do they order? Product. So all the customer information are stored in customer table. All the order that the customer made are stored in the order table. All the products that were ordered are stored in the product table. And there's supposed to be a kind of relationship between these three tables. We're supposed to define a kind of relationship with them. So looking at these three tables, the order table contains orders of products like that, and like that. So we're going to look at the kind of relationship that this table would have. And why do we need those relationships? So that we would be able to pull data from table order and at the same time call data from table product and at the same time call data from table customer. There's supposed to be a kind of relationship that will allow us to be able to connect to the other table and call for data, and at the same time we will get information concerning that table. So there are basically three kinds of relationship in the database. We're going to start with the first one, which is called one-to-many relationship. One-to-many relationship. The other one is many-to-many relationship, and the third one is one-to-one relationship. I'm going to explain how each of them work. In a one-to-many relationship, we are looking at a scenario whereby for every one customer, there are so many orders that the customer has made. You know, it's possible for a customer to order several products. A customer could order products like cornflakes, like milk, like sugar, like cutleries, all from the same company. So that is it's typical the scenario of one-to-many relationship. Also, another scenario we can look at in a one-to-many relationship is a teacher is assigned to many students. A teacher is assigned to many class. So a teacher is one-to-many relationship. Another scenario is doctor and patient. A doctor attends to many patients. It's not many patients attend to many doctors. A doctor attends to many patients. That is a one-to-many relationship. So if you look at our table in the slide, we have the customer table and we have the order table. Looking at our customer table, we have how many rows? 1, 2, 3, 4, 5. 5 rows here, isn't it? We have the 5 columns rather. We have a column customer ID, we have a column first name, we have a column last name, we have a column email, and we have a column address. Looking at the order table also, we have various columns in that order table. So the customer table basically is information about the customer, and the order table is information about the order the customer has made. How do we link these two tables together? How do we link these two tables together? It's very easy. The best way to link these two tables together is here in this slide. What I'm going to do is, you know, earlier I was talking about the primary key that makes the table unique. So if you look at this customer table once again, every customer has a customer ID. So Mitchell has a customer ID of 367. That is the customer ID of Mitchell, 367. Then Lynn has a customer ID of 368. You can look at the customer as a customer ID as like your employee ID or your matric number or your social security number. Those are those are unique keys to you. Your passport number, international passport number, is also a unique key. So those are what we can define. I can use as an example of a primary key or a unique key. So look at the order table too. Every order has a unique key called order ID. We have the order ID 1198, order ID 1199, order ID 1200. So it means for every order there is a unique key assigned to it. So when we talk about one-to-many relationship, after a one-to-many relationship is possible, the best way to implement a one-to-many relationship is just to look at this table down here. If you look at the order table here, you will notice that I have now added a new column to the order table here, and in the order table I have added the customer ID to that order table. So by adding the customer ID to that table, it automatically means that I have created a one-to-many relationship scenario, meaning that I will be able to reference table customer because I have added the customer ID into the order table. It means it gives me access to be able to get information from the order table because I have added the customer ID to this table. You notice it wasn't there before, but it doesn't remove it from the customer table. It's still in the customer table, but we repeated it in the order table. So automatically it means I can access the information in the order table. There's a relationship now between the customer table and the order table. The relationship is the customer ID that have been imposed into the customer order table. So this customer ID that is showing here is called a foreign key. It's a foreign key. It means it's a foreign key, but it's a primary key in the customer table. But because it's showing in the order table, automatically it's a foreign key. Do you get the point? Another relationship we can hope we are getting what I'm saying. If you are getting it, said okay. If you are getting what I'm saying, type okay. If you are getting and understanding what I've said so far, type okay. Okay. The other kind of relationship I mentioned earlier is the many to many relationship. Okay, Tolu has responded okay gradually. Okay, well, no problem. Gradually you get the point. You get it. By the time we start the practical, you have a feel of what we are talking about. The other kind of relationship, we talk about a one-to-many. We are going to talk about a many-to-many relationship. A many-to-many relationship is a situation whereby you have a possibility of having two tables giving each table giving a one-to-many relationship. Alright, so if you look at the diagram I've stated here, we have two tables. I'm going to explain the three tables you can see here. You have a table, author table, you have another table, book table. There's a possibility that many authors write many books. Many authors write one book. One author writes many books. Many authors write many books. You know, it's possible for many authors to write many books. Look at, for example, book ID 115. 1145. 1145 is written by two authors. Yeah. You can see 1145, 1145. 445, 447. So because this is a scenario of many-to-many relationship, which is not usually allowed in database, what we do is to create a joining or linking table. So the joining or linking table is going to create a scenario whereby the tables, the columns that are causing the confusion are isolated and they are put into a new table. So in this situation, the author and the book are the one causing the confusion, because you know it's possible for several authors to write several books. in that situation, that is a many-to-many relationship. So we know that the table, author and the book are the confusion. We create a new table and we call the table author ID and book ID will be the columns in that table. Why do we bring the author ID and the book ID? When you see the two columns that are causing confusion, that causing the many-to-many relationship, we bring the primary keys of those columns and put them in a new table entirely. So in this situation, we created a new table and the two columns that are causing the confusion are separated, isolated, and put in that column. That is why you have a scenario where we have author ID and book ID. Both of them are called a joining or linking table. So in that situation, we are going to link author table to the author book table with a one-to-many relationship, and we'll also link the book table to the author table in a one-to-many relationship. So this solves the problem of a many-to-many relationship. So from author table to author book and book table to author book, we created two scenarios of one-to-many relationship. So just put in mind, anytime you have a many-to-many relationship, you break the table down, you create a joining table or a linking table, and that table solves the problem of many-to-many relationship. Yeah. Hello. Sorry. Can you hear me? My internet is back. Hello, can you hear me? My internet is back. Okay. All right, so we're talking about one-to-one relationship. Most times, one-to-one relationship is always, the scenario is, it's a situation whereby a table is joined to itself. Yeah, the table is joined to itself. So look at this table here. We have employee table and contact information table. So in a situation where you have a one-to-one relationship, you just the one-to-one situation, one-to-one relationship is one man, one wife. That is the basic scenario. But if you look at this data now, what do you think to be done in a one-to-one relationship? The first data, the employee table, contains employee ID, first name, last name. The other one contains employee ID, email, and address. So in that situation, what we do is just, if you have a table that has email and address, what you do, you just bring the employee ID and let it show in that table. Makes the contact information complete. That is a one-to-one relationship. We brought in the employee ID and let it show here. That's a one-to-one relationship. But most times in database management system or database, you hardly use one-to-one. Most of the one you will use is one-to-many relationship. All right. Properties of a database management system. The properties of a database management system, when we think of database, I want you to look at it from a transactional perspective. You know, when you think of database, I want you to look at it from a transactional perspective. Okay, a transaction, what is a transaction? For example, let's say you want to transfer 5,000 to from your account to another account. You know, when you transfer the 5,000, your account is supposed to be decreased by 5,000, isn't it? While the receiver gets a 5,000 increase in his own account. If both of these transactions occur, then we can say it's a successful transaction, isn't it? That is a successful transaction. We can carry the same scenario to database. For a transaction to be successful, it has to pass the ACID test. I call it the ACID test. It must be atomic, it must be consistent, it must be isolated, and it must be durable. These 4 things must happen in a database. These are the 4 things in database handle. These are the 4 characteristics of every database you can think of. They must pass the ACID test. When I say atomic, what does this really mean? This means that the transaction must completely happen or not at all, and it returns to the original state. Like the example I gave earlier. Let's say you are trying to debit your account by 5,000 and you are trying to credit Mr. B's account with 5,000. Both must happen. If one happens and the other doesn't happen, then it's not a successful transaction. Then it must be rolled back. That means your 5,000 must go back. That's what we call reversal. It must be rolled back and it hasn't occurred. It wasn't successful. Then the consistency part. This just means that your transaction must follow integrity rules found in the database. It can't follow its own rules. It has to follow the rules that are defined in the database. That is where we talk about the consistency aspect. Then the isolated. The isolated means you have a scenario whereby you are trying to work on a database and another person is trying to work on the same database. What we normally advise actually, but what the rule of thumb is, as long as somebody is working on that particular database, the database must be locked so that another person cannot update. It is when the person that Mr. A has finished updating what he needs to do, that is when Mr. B can update at the same time. You cannot do it simultaneously. It's just like you trying to transfer money to an account and another person is trying to transfer money from your same account. Both transactions cannot go at the same time. One must happen while the database must be locked. When you finish, the database will be open for the next person to be able to do transaction. Then durable. Transaction must complete successfully and database management system gives a guarantee. That is what it means for a database to be durable. Once a transaction completes successfully, there must be a guarantee that yes, this is successful from the database management system. So those are the 4 basic features of a database management system. Those are the features. If there are any questions so far, you can pass your questions in the chat box. I will get back to you. Pass your question in the box and I will definitely answer them. Just start your question and I will get back to you. So we are moving to the next subtopic, which is Introduction to SQL. SQL means Sequential Query Language or SQL. Some people call it Sequential Query Language, some people just call it SQL. All of them are allowed. So what is SQL? What does SQL do? Why do we need SQL? We are going to look at it in details in this class. So SQL is is the language we use to interact with our database. SQL is a declarative language. It's a language we use to interact with our database. Your database contains data. For you to access that data, you need to be able to write, to get the data out, you need to be able to write SQL syntax. So, but there's a big difference between SQL and conventional programming language. There's a difference between the two. What is the difference between the two? Basically, the difference is that in SQL, it's more of a declarative programming language, meaning that when you have an SQL, you want to get, let's say this is your table, your database. You just write your SQL that you want to get, let's say you want to get information from your database for the price list that are $40. Very easy. But if you have to do this in a programming language, you're going to write a code like the ones I've written down here. You see? You need to declare the procedures, the steps that the language will go through to be able to get all the books that are $40. But if you're using an SQL, what you just, let's say you want to get all the books that are $40. This is just this one line. This is just the one line statement you write. Select from books where books list price is $40. Select from books where book price is $40. So that's the way to just write your SQL language. You can see it's very straightforward. You just tell the database that you want books, or you want all the books price where their price is greater than $40. As simple as that. That is why we need an SQL, and it's going to return all the books that are $40 and above. We hope can hear me. Say okay. Type okay if you can hear me. The next topic we are moving to is data modeling. This class is likely to continue next week because we might not be able to cover everything today. I'm thinking we should continue the hands-on next week, because we have to continue the hands-on today. It's going to take us another 2 hours or 1.5 hours to do that. So we are moving to data modeling. Data modeling. Data modeling is the crux of today's class. Is where we've all been talking about. All we've been talking about today, we now want to be able to build our schematics, our skeleton. Here we are going to be designing our database schema. We are going to design our tables, our columns, our primary keys, and relationships. But one thing you should know is very critical that once you want to start a database, don't just jump into the software and start writing, creating your data, creating your tables, creating your columns. Before you do that, you need planning. You need to understand the reason why you want to have a database. You need to have a plan. So when we talk about planning your database, you need to know, why do you need the database? What is the point of you designing that database? If you say, I just want a database to store products and other information, maybe you are into retail, this your approach is good, but it's not good enough, because it's open-ended and it doesn't give room for expansion. It doesn't give room to convey all the ideas you might want to put in that database. Look at the other scenario that I put here. What is the point of you having a database? We want to help our customers to find books, discover what others thought about them, purchasing and track their orders, contribute their own reviews and opinions, and learn about other products they might like based on people with similar reading habits. Look at this person's reason for having a database. You can see that he has thought about all the possibilities of what he will use the database for, and he has given you his statement. It's more specific, it's more detailed than just saying you want a database for this. So that's why I said you need planning. You need to sit down, you need to think and think about, okay, why do I need a database? What do I need a database for? Then the next thing we need to consider is physical items that are available. Because if you are deploying a database, before you deploy the database, I'm sure the organization has been gathering their information in one way or the other. They could have been gathering the information through forms, through sheets, through some print. There could be some printout, there could be some handout. So you need to ask information. Okay, what do you have in place? What do you have already? And some might have files, documents. Some might have people and expertise. An existing database will exist, such as Excel sheet or a text file or a notepad. If you have all these things, you don't discard them. You look at what is relevant from all those information and find a way to integrate them to your database. So those are some of the things, because when you are designing a database, there is a way they've been gathering their information somehow. They could have a database that is not effective, they could have a database that is not functional, they could have a database that is haphazard. And you coming in, you look at all the scenarios there and be able to provide a better solution. You're not going to accept all they have, but you're going to see what's going to work for them and make it work for them. So in this table here, we have different attributes. And by the way, we have different entities. Entities are tables, while attributes are columns. Another name for entities are tables. So we have several tables here. We have the customer table, order table, product table, like that, it goes on. Customer places order, order contains this order item, order items refers to product. You can see the scenario. Then customer on blog post belongs to author. Paycheck for employees, employee is in a department. So from this database, we have several tables, and you can see the tables are this is just, it's not really a relational table. It's just a table telling us that it's just a database telling us the kinds of tables we can have. We've not really joined them together yet. Those ones you see me putting are just to simplify how the table are joined to each other. So a typical table, I said earlier, a table will have rows and columns. The rows and columns are what you define when you are building and setting up the table. So a typical table, like let's do the customer table, you're going to have several columns, and those columns are the attributes. They are name, email, address, and phone number. So if we look at them, we could break them down into this table like this, and give a characteristics to all the various columns in the employee table. In this employee table, if you look at this employee table, we have several columns in it. There's a column called first name, and I put the data type is supposed to carry. It's called character, meaning it stores only alphabet or text, as the case may be. And I also wrote not null. It means it can be empty. Not null means if that field must be filled. It can never be empty. Same thing goes for last name, date hired, and the right. Look at address line 2. It's not compulsory you have 2 address. That column can be null. That is why you see a null button there. So this time, what we are doing here is trying to put in the rules regarding. We are trying to set a rules regarding our database. Look at the email. The email is containing character, means text, and it can be empty. And if you look at it, I also put pattern matching, meaning that you can't just type any arbitrary letters there. It must follow the pattern of an email. I'm going to configure it in such a way that if you enter anything that does not have @ if you enter anything that doesn't have dots, it won't take it as an email. It will flag an error. So you can see here, we are trying to put in our rules by defining the rules on each of the columns the table is going to have. Another thing I want us to talk about is primary key and composite key. We've already discussed primary key earlier. It's a unique key, and it can be also incremental. Even if your database has no unique, your table has no unique information, you can tell the database to create a column and call that column primary key and give that column a name and make it auto incremental, meaning that it will just be like serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The list goes on like that. So, but there's another scenario I want us to look at, and that is where we are going to be stopping today. It's called the composite key. You know, I said earlier, it's possible for your table not to have a primary key. So you can look at your table and get 2 columns and merge those columns and call those 2 columns a primary key. So in a situation where you use 2 columns as primary key, it's called a composite key. You call the 2 columns primary key, you merge the 2 columns together to call primary key, they are called a composite key. So I think we are going to stop here for today. We are going to continue same time next week. But so far, how has been the class? Did you gain 1 or 2 things from the class? Just say yes. If you don't, say no. If you gain 1 or 2 things from the class, say yes. And if you don't, say no. All right. So this brings us to the end of the class. Till we come your way again next week, have a wonderful time. We're going to share the video of today's class on the social media, so you can always watch it again. We'll send a link of the video to your email, so you can always watch it again, time and again to get some of the points which you might not have gotten during the live class. Thank you for your time, and now have a wonderful week. Goodbye.